End of the day, I would like Mr. Alirehan, Engineering Manager, AI Vision Products at Keep Truckin', to conclude the day with the last tech talk and speak about the AI for driver safety. Currently, Ali Rehan is leading the core AI and vision team at Keep Truckin'. As a product manager, he launched the Dashcam product from the ground up. He's also co-founder of Rubik App and Ingrain and has carried out research work constructing 3D structures using a single camera. Mr. Ali, we're glad to have you with us today. Please take this forward from here.
Cool. Thank you so much. It's a pleasure to be here. And amazing talk, Samya. Like now I know the reason why I'm spending too much time on Xbox. But cool, yeah. So I think like quickly again, just to introduce myself, my name's Ali. I lead the computer vision and AI team at Keep Truckin'. I have been at Keep Truckin' for almost 4.5 years now. And I initially started as a product manager on the driver safety products, but then I switched to engineering because I was super excited about the impact AI was going to have on driver safety, and I wanted to be close to it. So today I'll share more about why driver safety is important, the role AI is playing in it today, and a little bit about how we at KT build our best-in-class AI features in the space. So to start with, just a quick overview on what's Keep Truckin', what do we do? So our mission is to improve the safety, productivity, and sustainability of businesses that power the physical economy. So when being deep in the tech sector, I don't think a lot of us appreciate enough how much our lives are impacted by thousands of traditional physical businesses around us. From agriculture to logistics and transportation, these companies help us enjoy the lives we live today, and they're really the backbone of our economies. So our goal is to build technology that makes these businesses more efficient. We want them to optimize their operations, save more money, and earn more money in this whole process. To do this, we are a super strong team of 2,400 people with over 400 rockstar engineers. We've raised about $450 million from the top investors in the Valley, and today we serve over 100,000 fleets of all sizes across North America. The core of the company's product offering is a range of hardware devices that brings the fleet's assets online. We have a vehicle gateway, which is connected to the vehicle using the CAN port, and it helps us track the state of the vehicle and their location. We have this dashcam device that is mounted in the truck, and it helps us detect risky driving behavior. We have environmental sensors that help fleets monitor their cargo. And then we have an asset gateway that's used to track the fleet's trailers and other non-powered equipment. The data that's collected from these devices really helps us optimize the fleet operation and create a real impact on the day-to-day operations. So today we offer a wide range of products from safety manager focusing on driver safety and compliance to dispatcher who's tracking assets and costs. Our platform is the operating system for a lot of these fleets. And it's the best part is it's a single unified platform that breaks silos between different functions and makes the team more efficient. So with this vast network that we have built in the last few years, so of over 100,000 fleets today, we've built a rich understanding of how trucking fleets operate in the US through tons and tons of data collection. For context, our vehicles drive over 2 billion miles every month, and we've collected data sets that are roughly 4 billion images in the last few years. And this data is the core of our AI strategy and products. So the rest of this talk is basically about how we leverage this trove of data to solve the driver safety problem. So let's talk about why driver safety first. Like why is this particular thing important? The reality is if you're a truck driver and you're on the road, with a certain degree of probability, you're bound to run into accidents. It's an unfortunate situation, but 6% of trucks run into accidents every year in the US, and the cost of these accidents is pretty high. if you're in an accident, the average cost is about $96,000, even if there's no injury. If there's an injury in a crash, it goes up to $200,000 on average, and fatal crashes can be up to $3.5 million. And what studies have realized is that drivers' actions are probably a critical reason in a lot of these accidents. So what fleet managers want is a way to like they're really looking for two things. One, in a lot of times, in some cases, like drivers are not the cause of the accident. They might have some reason to blame, but they're not the cause of the accident. So they want to show that my driver was not the reason why this accident happened. So they want exoneration piece, but they also want prevention. And dash cams can be used for both of them. The other thing that we realized was, like, generally, like 80% of the risk comes from 20% of the drivers. So on the prevention part, dash cams and technology can be used to identify who those bad drivers are, what's their risky behavior, and then coach and train them so that they can improve their performance on the road and prevent accidents. So this is, with this context, like we built AI technology and AI dash cam, and through our dash cam today, we are able to get a lot of insight into driver behavior. It can be very basic, as such as speed, acceleration, and braking patterns. And in fact, what we've realized, and what a lot of smart insurance companies in US have realized, is that even these basic parameters or basic behavior aspects like hard brakes are a very good indicator of the risk profile of the driver. But then we are taking it to the next level with our AI dash cam, which not only tracks all of these basic things, but things like close following and cell phone usage and unsafe lane change. All of these are these three are probably the biggest causes or reasons of the accidents in US. So we are able to detect them using our camera. To show you a quick demo, here's what our close following feature does in real time in the field. So if you watch this, if you look at this video, we are able to very accurately track the lanes and the other vehicles in the environment, and we are able to detect the distance from every other vehicle in the environment as well. So this 0.9 or 1 number tells you how long it would take this truck to get to that point, and trucks are supposed to maintain a distance of 6 seconds to be safe on the road. All of this is happening in real time on the edge using a single camera that we just ship to the customers, and they install it in the cabin. This is a demo of our cell phone detection feature. If you look at this video, it's pretty hard to even make out the face of the person in their phone, but our models are able to detect this very, very accurately. Please keep your eyes on the road. On top of this behavior, what we've done, we've built a very sophisticated algorithm that ranks the drivers. So we call it Drive. Basically, what it does is it utilizes the power of our massive network to determine like what the typical behavior of multiple drivers on every single small road segment in US. And then we map the every event on that road segment. So if you're on a road where everybody is applying relatively hard brakes, for example, when you're going downhill, everybody is going to apply brakes. We don't penalize your brakes on that downhill segment. So we take that context into consideration. And with this strategy, our Drive score is almost like 5 times more accurate than the highest publicly available claim of predictive accuracy. And in fact, like when you compare the worst 20% of drivers in our network to the top 20%, these bottom guys are around 170% more likely to get into a crash within the next 3 months. And we've seen this over and over again in the past few years. So this is what we offer today. But now, like switching gears a bit, I want to tell you about how we build these features. This like we keep saying this term like magical experience. In fact, this is something that our customers coined. Like when we shipped the product, they compared our products with some of our leading competitors, and the feedback that we got was our experience was very, very magical. Like you would pick up your phone and the camera would start beeping. This is not something that we typically see in the industry. So a bit about how we build this magical experience now. So the first thing, this magical, amazing experience that we've built is not a coincidence. It's a result of a very deliberate first principles approach to build the right product. And I'll explain what it means by what I mean by that by using the cell phone distraction as an example. So in the vision industry, there's a standard way of detecting driver distraction. You take an image, you detect the face of the person, then you detect the facial landmarks, which are the key points like eyebrows, nose, lips, ears, or the jawline, all of that. You use those landmarks to estimate the pose of the person, so you know where they're looking at, and based on that pose, you try to estimate whether the person is distracted or not. And this sounds fine in theory, right? But before committing to it, we wanted to see whether it worked in realistic trucking scenarios or not. And what we observed was it didn't work in almost 90% of our test cases. So we then decided that, okay, if the standard approach does not work, let's go to a bunch of industry vendors and see if they have solutions that can work for us. And it turned out that they were almost using the same strategy, and it didn't work for us. So to meet the quality bar that we had set for ourselves, we went back to the drawing board to figure out the right AI models to solve this problem. And after a bunch of experimentation, we invented a new way of solving the distraction problem. We use what's called multitask learning to build a single model that detects distraction way more accurately and efficiently. The idea here is to decide if the driver is distracted, you have to detect driver's face, their body, pose, and location of the phone. But instead of solving all these problems individually and explicitly, we created an AI model that just detects distraction by observing a bunch of factors like driver pose and location of their phone and the face. And the reason why this works better is you're not creating hard constraints, but a framework in which AI can learn the relationship between all these different things. For example, what's the typical pose of a driver when they are distracted versus when they're not? And with this framework, the AI is able to learn and generalize more efficiently. So this is a way more flexible and scalable way of building AI models. And the result is that our models perform significantly better on all our standard tests. It's a single model, so the feature can run really fast on the edge hardware. And this model can be easily extended to solve a bunch of other unique new problems, but just adding relevant data. And we've in fact already done that for a couple of features like seatbelt violation. So we validated our technology internally on our own data sets, and we compared our vendors, but that's not the only thing that gives us confidence on everything that we built. We've tested it heavily like on self-driving car data sets where it beats the state of the art in a lot of cases. Some of our technology components have been vetted by AI experts and published at top conferences, and we have multiple patents pending on our technology work. So this is a quick overview of how of our core strategy for our AI models, but then I believe that building the first model is just maybe 30 to 40% of the work, and the real work is starts when you've deployed the model. So once we are in the process of deploying these features and rolling them out, one of the biggest questions that we have to answer generally is how do these models perform in the real life, and how do we improve them? And I think so before I want to talk about before I go into the details of that aspect, I wanted to share this image from Andrej Karpathy. He's the director of AI at Tesla, and arguably the top computer vision practitioner in the world. In one of his talks, he shared this image to highlight the complexity of building AI features and improving their performance in the field. So any real life practical AI product has to solve a bunch of long tail, he has to solve a long tail of scenarios. And this image really highlights that problem. So it shows that it's easy to solve the first 90% of the problem by addressing the most frequent cases that your product will encounter in the world. to get to 99%, you have to solve for variations and infrequent scenarios, but still like they're commonly observable. So you can find them. But as you go deeper after the decimal point, you are up against crazy scenarios that are extremely rare in the real world. And the challenge is to find enough of them to train your models on those crazy scenarios, because your AI is going to run into them. So the result is like to solve this problem, you have to invest in tools and strategies that help you identify and solve the long tail problem. And at KT, we've invested heavily in building processes and pipelines that help us find these problem areas and failure scenarios. We have an in-house team that reviews every single video that's uploaded and provides insights on a lot of different factors. Where like they tell us about the scenario of the video, for example, like where did that event happen? Was it a curved road, straight road, highway, local road, weather, like bunch of scenario information like that. And then they also tell us about the quality of our AI feature in the field. So I know precisely like the videos which had bad lane detection, for example. And this happens 24/7, 365. And for the last few years, like we've been collecting this data. So today we have over 10 million videos reviewed through this process. The result of this process is we are able to build very detailed insights on the model performance. For example, like this is real data that we collect that we collected a few months ago. With this data, we realized that our model performance was slightly degraded on low light and curved road scenarios. So we improved it. Also, we realized that like with this data, we learned that there were maybe only 4% videos from nighttime scenarios. This could have been because of a false negative issue. So we checked and found that it was actually the driver behavior. Most of the drivers were driving during the daytime, so we didn't have any nighttime videos. But we were able to answer those questions very quickly because we had this level of insight on the problem. Now, so this building this insight is one part, but we are like it's only useful if you are able to quickly act on this. And one thing that we realized was like a major bottleneck for a lot of AI companies is the number of concurrent model experiments and that they can do, and the speed of their deployment. And so we invested like our upfront investments in this end-to-end infrastructure helped us. And today we can run dozens of experiments per week and do almost weekly model updates in the field, which is very rare, even in some of the smartest AV companies. To do this, to do all of this, we've built these pipelines where not only like as soon as we get new insights from the annotation team, the data gets more detailed fine-grained annotation. It goes to our data store. New models are trained within a few clicks on a few clicks, and then they go to a simulation test bench where they are validated on hundreds of and thousands of previously recorded videos, and we use all of that validation to confirm whether the model works even before sending the first version out in the field. Like sending model to the field. And for reference, like this is like a quick snapshot of our results on the recent model trainings that we did. In the left, the table shows you how our performance changed on a set of almost like 2,500 videos. The previous lane and vehicle models, precision, recall accuracy versus the new models. And then on the right, we show you how our fast iteration process helped us improve the accuracy of our model within a matter of 2 months. This kind of speed and this kind of iteration speed is pretty rare in the industry, and we are very proud of everything that we've done here. So overall, our products have, like, because of all the work that we've done, both in terms of the core AI product and the Drive Score and the product that we've built on top of these core technology components, we've done a number of studies, and we've observed about 35% reduction in collisions for the fleets that use our products actively. And this is all a result of a bunch of these different things. We build the best-in-class AI models to solve these problems. We have built large-scale infrastructure to help us track and solve the long-tail scenario. And in this process, like we with this process, we are able to create a very meaningful impact. And I believe we are one of the few companies in the world with this huge opportunity of building the right computer vision models and products, and deploy them on the scale, and have this meaningful impact. So I'm super excited, super proud of everything that we do here at Keep Trucking. We are actually saving lives on the road. We are pretty proud of that. And so if any one of you is interested in learning more about any of the work here, or the roles that we have open, we are hiring like crazy. So feel free to reach out to me and a bunch of different, like there are other people in the conference from the company. So reach out to any one of us, and we'll be happy to share more details of the product and everything that we do. Thanks.
Thank you so much, Ali. This was amazing. I'm not just thanking you for your presentation. Thank you so much for you and Keep Trucking and all of their support in making AI Summit 2021 possible.